So, I'm Kelly Norton, Joel Weber. We both are part of the Google Web Toolkit core libraries team, which means that we write a lot of the widgets and a lot of the libraries that hopefully many of you use often. And what we found is there actually there's some differences in writing apps versus writing libraries. So what we found writing libraries is that there are a number of sort of sometimes uncommon advice, sort of counterintuitive advice that comes up when you're writing libraries as opposed to apps. And so we're going to talk about 10 of those today. But first of all, the first thing is Joel's going to actually tell us what those differences are.
The main thing you've got to consider, and I think this is fairly intuitive, but it's easy to forget when you're just banging away on code and writing things. So when you're writing application code, what you want is for your application to do a particular thing. You have a single use case and you solve it. When you're writing library code, you know, this part again is fairly obvious, but what you're trying to do is write code for other people to use. Okay, a little more general, a little more abstract, better abstractions, what have you. But what also really matters is you've got to remember that people are paying for what you do. So the cost of a bad decision in application code is limited to that application and may not matter for its particular use, whereas the cost of a bad decision in library code is multiplied by the number of people who are actually using it. So, you know, we often hear, we often hear complaints like, are you advocating premature optimization on this point, let's say on a particular code review or whatever? You know, this seems good enough, let's just go with it. But it's not premature if it's about to affect hundreds or thousands of people. Sometimes that is post-mature if you wait, is another way to put that. So just keep that in mind, bear that in mind as we go through these points. I think it'll be fairly self-explanatory as we move through them. But just remember that if you're writing libraries for other people to use, you know, that the cost of every decision is multiplied. That's the main point I want to make about that.
So we're actually going to structure most of this, like I said, as 10 points. And we're just going to go ahead and jump right into them. And we're actually going to point to, in a lot of cases, specific examples from the libraries and sort of, in a lot of cases, give you a reason why it's a good pattern, and in some cases, why it's a bad pattern, and we've had to live with it. So the first thing I'm going to start with is probably what I think is the most important thing we've realized in doing the libraries. And that is, when you're designing something new or changing an existing piece of the library, design to real use cases, not someone's fantasy. And what I mean by that is you often get people who come up and say, you can always tell, they start with, it would be really nice if, or doesn't it make logical sense if that took a, this sort of thing, as opposed to the people who come up and they say, I need the following thing to happen. I think that to make that happen, you could make these changes, right? And so if you sort of always work to the abstract, you often don't come out with the most useful thing. And as a matter of fact, we have a couple of examples. And Joel, I know Joel knows a lot about this first one, so I'll actually let him take that.
Primarily because I'm responsible for it. So in the code sample here at the bottom, we see tree.add item or tree.add. Both of these cases here, it can take a widget. This seems like a perfectly reasonable abstraction. Why ought I not be able to add a widget to a tree? So, seems reasonable. We had a lot of people telling us early on, after their very first release, we really need to be able to add widgets to trees. Unfortunately, what we should have asked is what they actually wanted to achieve. Really, what was their application actually going to use this for? Because it turns out in about 99.98% of cases, they wanted to add a checkbox or an image to a tree. Those two cases cover almost every tree that I've ever seen that has a widget in it. Turns out that is a whole lot easier to do than adding widgets to trees, and now there's actually a fair amount of overhead, and the code is a fair bit more complex to deal with cases that look like the code you just saw, where I added a tree to a tree. That's really not a very useful case, and in fact, it actually makes the UI behave kind of strangely because then the keyboard focus behaves somewhat strangely and correctly in a sense, but essentially not in a useful way. Had we simply said, we're going to provide a few specific instances of, we're going to allow you to add checkboxes, images, maybe radio buttons in some cases. But those very specific cases found a simpler abstraction that would have handled those instances. It would have been a whole lot easier, simpler, and faster. Now, however, we do support adding arbitrary widgets to trees, so the tree will always have that API because you can't back out of it once it's been written. Most people don't actually need that level of complexity, though, so everybody is now paying for that. That's one example where we have really, we have paid for that mistake, and the cost is not insignificant. Because the other thing I didn't say about library code before is that once you write it and anyone uses it, it's a pretty important decision to say I'm not going to support that anymore because you've got a bunch of people using it. Well, either you've got to keep supporting it or you've got to abandon your users. It's one or the other. So those decisions, they carry a lot of weight and they carry a lot of implications that go on into pretty much forever into the future. If we could switch back to the this. Actually, I'm going to let Kelly talk about this since I think he either wrote or used this stuff more than myself.
So what Joel just described was a case where we've sort of learned by doing the wrong thing in the first case. So just to salvage our reputations here, I'll show you a place where we actually prospered from looking at use cases ahead of time, and that is many of you have probably used Image Bundle. Something that only those people on the contributors forum will know is that the first version of Image Bundle actually returned an image widget. Well, it turns out there are all sorts of use cases where you actually don't want a distinct widget for each case. One is I have a little arrow that points to the left, and when I click on something, it changes to an arrow that points down, right? Just sort of changing the image state. In HTML or in the actual equivalent JavaScript would literally just be a change of a CSS style. But if we had left Image Bundle returning an image, you'd have literally had to have done some additional DOM operations, putting an image in, taking an image out, and we would have ended up in an inefficient scenario where our API was forcing us to do something that was just not the right approach. And so it caused us to revisit what Image Bundles returned, and we ended up with something that was at first pretty counterintuitive, and that is Image Bundles returned this abstract image prototype, which was sort of a way to apply an image even to an existing image. So we were able to take care of that case where you had an image already in the UI and you wanted to flip it to a completely different state, and it actually could do the efficient thing. It turned out this also covered another use case, which is I want to get an image and just take the HTML string and use inner HTML to get some speed ups in some cases. It actually covered that. And also it gave us a place to expand. If other additional use cases come up where we need to construct an image in another way, we have abstract image prototype to save us. So that's one of the good examples. Okay, so let's jump to number one. We start at 0, of course. Here's another one. We don't have any code attached to this one, but create independently useful pieces. So don't prematurely wire everything together. Actually try to make each of the individual pieces isolated and useful by themselves. You want to talk about some examples here?
Yeah, the most obvious example of a real success case here is, as listed here, the JSON, XML, and request builder libraries. Request builder is just a way to build HTTP requests so that you can make them to the server. It turns out there's a lot of cases where people want to just go and get a chunk of text from a server or whatever. They want to parse it themselves. So that is separate from XML and JSON parsing. It's also separate from RPC mechanism. The RPC mechanism uses the request builder under the hood, and that is strictly coupled because the RPC mechanism does in fact need a way to make requests. But XML and JSON parsing turn up in a number of instances that have nothing to do with HTTP requests. So it's really trivial to wire them together, make a request, pass it to a parser, but there's no reason that the parser need know about the request, because if it did, you'd never be able to get data from anywhere but the server. And you may have JSON coming from God only knows where, or XML embedded in your app, whatever. It's not up to us to predefine those use cases. So it's nice to have use cases, it's really important, but it's also, when something is sort of obviously and naturally decoupled, it's nice to leave it that way. It's important to leave it that way so that you don't hamstring your users going forward. There are probably other good examples, but that's the one that really struck me the most.
Cool, so let's move on. Practice number 2. Don't use a widget when all you need is HTML. And part of this, and this is another one we have to remind you, we're talking about library code. So we saw a lot of very cool demos this week where people have actually said, I just use widgets for everything. What are you guys always talking about using DOM elements? Which is awesome for us because it sort of proves our point about this one. And that is, if you actually don't need to, so widgets sort of have special properties. They basically give you the ability to handle events. If you don't need to handle events, you're perfectly okay just using DOM elements. As a matter of fact, you can actually handle the events in a widget upstream. And that's actually what this shows. Do you want to describe this?
Yeah. This is a very simple example, but basically, I'm imagining some widget that I've created. You'll notice that you'll see this kind of code in a lot of widgets. It just creates elements for a lot of sub pieces. In this case, it's just an image that we're appending to whatever the main element here. This is an incomplete constructor. But you'll see this, for example, in the tree item. Tree item is not, well, first of all, it's not itself a full widget because it doesn't need to be added to arbitrary other things. It can only be added to trees and other tree items. So that allows you to restrict the API in some sense. But also, it creates DOM elements for everything. Now, this complicates event handling a bit because the tree has to handle all events. They bubble up to the tree. We then go back down and figure out where they came from and do the appropriate logic. And that's more complex. But the end result is probably an order of magnitude more performant, both in memory and in speed and setup speed and so forth. For those thinking, by the way, that the tree is already too slow, you're right, and we found ways to optimize it on top of that. But if it were built out of widgets, we would not be able to back out of that abstraction. So we would be in even worse shape. Whereas right now, I can look at it and go, okay, there's there are too many widgets, too many elements here. I've got a faster way to create these elements, but nobody knows about that abstraction. There is no abstraction there. It's hidden implementation detail, and it's always possible for me to make it faster because I have not committed early to an API.
Cool. All right. Number 3, I like this one. Design with compiler optimizations in mind. Scott Bloom has worked really hard, and Bob Vaughter as well, recently to actually make some really cool compiler optimizations. And Matthew as well, who's an open source contributor. So then the thing is there are ways you can write your code so that they take advantage of what the compiler can do. Especially in cases where you have uses that are divergent. So you have some bit of code that is likely, one bit of code is likely to be on one app, but it's not likely, both are not likely to be in the same app, right? And you can sort of structure things so that compiler can work its magic. So I think I'll talk about the first one a little bit. So when we introduced image bundles, we talked a little bit before, trees of course still supported an old image API where you gave it a base URL and you passed in a string. And we really didn't want tree to continue to operate in that way, but we had an API out there and we needed to support it. And so thought for a while, we're like, well, I really don't want this to affect the image bundle case, which really is the most efficient case. And so we went in, we took a look at how this would work and put some inner classes in there, and we're careful about where we instantiated the inner class. And we actually got what we wanted, and that is the old way is still supported. You can still create a tree, you can still set image base, or you could create a tree and you could pass an image bundle. In the doing things the new way has no relic of the code from the old way. In other words, none of the classes associated with that functionality, none of the methods, they all go away when the compiler runs. So this is a great place where we were able to structure the code, sort of be a little bit disciplined, and we got a lot of return from the compiler. So what was our second one here? Oh yeah, an actual hardcore example here. Do you want to talk? You want me to talk? Okay.
You wrote it, but yeah. Kelly wrote this one. I'll just talk about it. So those of you familiar with the DOM class have probably looked at it and noticed that it is a bunch of static bridge methods to a deferred bound instance that it keeps around. The way that worked, I won't show this here, but if you open dom.java, you'll see this. It's pretty obvious. There was a static initializer, and in 1.5 that static initializer is gone because we discovered, for reasons that are a bit beyond the scope of this presentation, the static initializer causes it is speculatively run at the entry point of every method in DOM. So the end result is the compiled code looks like this magic CL-init call, which is class initializer, followed by the underlying code. It had two problems. One, you don't really want to call that thing, even though it's a very, very cheap call. You don't really want that call there every time you try to do anything on the DOM. But worst, it confounds the inliner. Because the amount of code that could be run there, it only actually happens once, but the amount of code that could be run is more than you'd ever want to inline. It would have to be fairly deep inlining, and it wouldn't work very well. So when we found this in the output, we said, okay, well, the inliner is better now. What could we do to make this problem go away? And as I recall, Kelly, correct me if I'm wrong, I reviewed the patch, but I've forgotten. There is one case early on where it speculatively initializes, does the static initialization code that it needs to do, but would otherwise have been in the initializer. But it's in a place that's only called maybe once or twice per app. So there's one little extra check in the very beginning, but then all the CL-init calls go away. The end result is that now when I call dom.setElementAttribute, that whole thing gets inlined from JavaScript all the way back out to the call site, and I've actually written apps where the DOM class went away. It just disappeared. That is pretty effective. Now I know that this is fairly inscrutable stuff, because if you don't know what the compiler is doing and optimizing, then it's kind of hard to know what these things are. These optimizations have been coming in a fairly rapid flurry lately, so we're actually still learning as well. But we're going to make a real point to document these practices. None of it should complicate your code in any significant way. Most of them are pretty simple transforms. If you do, little guidelines, do this, don't do that, and you'll be in a lot better shape. So as we document those, I think everybody else should be able to take advantage of that knowledge as well.
And while I'm switching, I'll take the chance again to remind you, we're talking about here writing library code. So, don't let this influence the way you write your applications. You really don't have to be this disciplined most of the time when you're writing your applications. Especially don't start out going, oh my God, I must write this class to take advantage of compiler optimizations. We're really talking about library code here. So, identify your invariants, make them immutable. This is a good general idea. Due to some characteristics of Google Web Toolkit, it's an even better idea here. I'll give you a lot of people don't even know that this class ever existed. Long ago, there was a class called Linear Panel, and Linear Panel would allow you to do this: create a linear panel, and then change its direction. How many actual use cases do you think there were for changing the direction? 0. We never actually really got used. But there was a lot of code to support the changing direction, a lot of code. And it was complex because it had to deal with, is it attached, is it not attached? So a much more logical solution, horizontal panel, vertical panel. That is almost always what you want. So,
can I say a word
yeah,
about
absolutely.
that? One thing I want to add to that is the initial linear panel took a direction in the constructor. The code would have been a lot less ugly had it not also exposed a setter. But in many cases, when you're going to expose, if you're going to pass an enum into a constructor, and that enum doesn't have 10,000 values, then you're probably better off just making subclasses. The code usually gets easier to write. It's usually a lot more self-documenting, and you're not losing anything by creating those extra types. Types are not terribly expensive. In cases where you have other invariants that aren't naturally separated out into specific subclasses, non-enumerated types, integers, strings, that sort of thing, but you don't want to deal with them changing, if it's inappropriate for any use case you're actually considering, then do pass it into the constructor. Constructors are there for that reason. There are cases where you don't want to do that, but whenever you can, the knowledge of immutability is extremely useful. Then make the field final so that you remember that it's never changing, that if you assign that value to a field. But if you can, horizontal panel, vertical panel, much more useful than linear panel. Think of that case.
All right. Practice number 5. Beware of implementation inheritance. I am not taking any of this because I know you have a lot to say.
Okay. So, first of all, this point is also a shout out to Bruce, who is not the largest fan of implementation inheritance. He'll talk your ear off about it if you give him the opportunity. And most of us have come to agree with him for the most part. So I get to talk about these two because they're mistakes that I made for the most part. Text box base. Anyone familiar with this class? Button base, focus widget, text box base. So two interesting things to say here. One, base is a relic from the .NET code that I was doing before I started working on this. They use base instead of abstract, base suffix instead of abstract prefix. So my apologies for the non-Java-esqueness of this. But more importantly, what is a text box base? What does it mean to you as a user? This is a perfect counterexample. I would argue that the answer is absolutely nothing. It is purely an implementation detail. There is no reason for you to know that it exists because it does not serve any purpose. Even worse, so rich text area. You'll notice that does not comment before the extends clause. It does not extend text box base because when text box base was written, it was purely an implementation detail that was meant to help aggregate some of the methods that applied to input type equals text, text area, password text, that sort of thing. But that's an implementation detail. Rich text area is implemented with an iframe, and none of that implementation is shared in any way, form, or fashion. And in fact, making it extend text box base would have been involved more work for absolutely no benefit. So in the end, not only did it not really mean anything, it was not a useful moniker. People probably never create fields of type text box base because it doesn't give them anything extra. But it's actually sort of semantically broken. The hierarchy broke when we moved forward. Now, if we had created an interface that captured the text boxness of these things, that would have made a lot more sense. But that's interface inheritance, not implementation inheritance. It's not to say that there's not a place for implementation inheritance, but think long and hard about what that type actually means to a user before you expose it to anyone, or you'll be stuck with something like this, like I will be for the rest of my life, most likely.
All right, number 6, make it work everywhere. We often get a lot of people who have really good ideas, but their first implementation is actually just geared towards a couple of browsers. And for us, that's sort of a non-starter because, I mean, one of the promises we make is that we really want to get you as close as possible to, I just write the GWT code, and it basically just runs everywhere. I mean, that is part of the value proposition here. And so actually, I'm going to let you talk about SVG.
One of my favorite topics, as you may well know. It's not that, and the assertion here is not that SVG does not work, although it is too slow right now. That probably will change. It's not that SVG should not be used for implementing some more abstract concept, but I've seen at least one library out there that was the SVG for GWT library. That's great, except that in case anyone hasn't noticed, 70% of browsers do not support it at a bare minimum, and probably never will because we all know which one that is. So creating an abstraction based on SVG or using SVG as the abstraction, its ideas and concepts, is basically unimplementable on some browsers. You know, SVG completely supports, rotated, transformed, scaled, skewed text. There is no way to do that on every browser reliably, to my knowledge. It is the right abstraction is to go and figure out what can actually be achieved on every browser and find the best abstraction you can build on top of that. We would like, as engineers, to build a better abstraction, but we are constrained by the reality. And, first and foremost, we started this project with the idea that it would be a pragmatic way to get your actual job done, and not try to enforce a particular worldview on the way that we think browsers ought to be at some point in the future. It needs to work on the browsers that are out there, end of story. Now that said, if you want to build an abstraction like this for your own application and you say, for example, I met someone earlier who said, well, all we have to do is support Firefox because we ship our application on XoolRunner. We just wanted to build it in a web browser. Great. You can do that, and you don't have to test on any other browsers, and you can build your own libraries if you need to that support only the browser that you're concerned with. I would generally caution against that because you never know when things are going to change. Like, for example, the fact that WebKit is a bazillion times faster. But there are cases where you can get away with this. We just can't do that in the core code.
Cool, and I'm going to talk about this next one. So here's another example, request builder. A lot of people have said, I actually want to send an HTTP head request. Why can't I do that? Well, the reason why you can't do that is because of a very obscure thing, which is in the WebKit code for the longest time, there was an if statement that said, if the method is not get or post, change it back to get. And the reason why they did that is because there was an obscure bug way down in NSURL that actually caused the browser to crash if you send a head request. So since we actually couldn't support it all across the board, we actually sort of tailored the API so that it would guide you in the right direction without blocking you. And that is, there was, for the constructor for Request Builder, you couldn't actually pass in, one of the enums that were available to you was not actually head. If you wanted to pass head for some reason, you just subclass Request Builder. But the standard API actually pushed you in the right direction and actually sort of gave an indication. And by the way, this was documented in the documentation as far as I remember. But it's an area where, and you think about it, it makes sense because how many people out there actually run most of their time on Firefox browsers and don't really test that much on Safari? It actually happens quite a bit. And so, you know, the chance that you are actually going to develop for a while only to find out that the thing did not work at all in Safari was high, right? So another case where we sort of erred on the side of making sure that we held true to our contract if it works everywhere. All right, practice number 7. We actually have found the builder pattern to be really helpful. It turns out that a lot of the APIs inside of the browser, they're constructed in such a way. They're bad. They're constructed in such a way that you can actually do things that don't make sense. You can, as we say, pull the crank on something before you've actually given it enough information to do the right thing. And so, you want to talk about this one? Okay.
So who here's ever used the XML HTTP request object directly? I'm sorry for all of you, having gone through the same thing ourselves. So as Kelly was pointing out, what happens if I create an XHR through whatever mechanism that I decide to use, and I set nothing on it and just call open immediately? What happens? It's in an invalid state. It's got several setters for a bunch of attributes and properties that are required, several others that are optional. Any of the required ones being missing, followed by a subsequent call to open, means that it's in a completely meaningless state. When you build an interface like that, you basically built a bunch of error states into your application that weren't really necessary. They're error states for your code to deal with. You've got to go in and check things and throw exceptions, or just let an NPE escape if you're really rude to your users. And it's error states for your users, right? They have to say, okay, I have to do this, 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 and this. There's nothing in the API that gives them this information. There's nothing that requires them to do this as a matter of normal usage. They just have to figure out that these things must be called. Read the documentation, which we all do before we use classes, right? I would rather just have the code completion and sort of the natural form of the API make me do the right thing, if the alternative is simply a failure. So the request builder class, and this is a gang of 4 pattern, right? The builder pattern. It's really, really useful because this request builder does not have. It has error states, but it doesn't have to deal with those until you pull the crank. And it doesn't have to deal with any internal error states on the underlying object and so forth. You can just accumulate all this state. When you pull the crank, you instantiate it in the underlying implementation. I believe it instantiates an XHR, sets all the appropriate things on it, and doesn't have to ever worry about that underlying object being in an invalid state. That's a lot simpler than the original, the original HTTP request object, which is still there but deprecated if anyone remembers, just has a bunch of overloads that require you to pass all this information in. Builder patterns are really, really nice when you find yourself with 15 overloads and 27 arguments in them. You're probably heading into builder territory. It would be a lot easier to break it out in this way. It would be a lot more self-documenting. It's easy to look up a couple of argument names, but when you've got like 15 of them, it would be really nice to see things like set user, set password, set header. It's a lot clearer to the people who come after you to maintain your code.
Cool. Practice number 8. OO is a tool, not a goal. If you've seen Josh Block talk, he actually talks about the specific example that we cover here. But it goes beyond that when you're in a browser. You want me to start on this, and then you describe the graph?
You might want to repeat Josh's point.
Okay. So basically you're saying, don't just go create objects for the sake of creating objects, right? Here's a perfect example, the dimension object. It's just X and Y. On top of that, especially don't make them mutable. You just end up with bad patterns propagating through the code, and it makes it really, really hard to optimize from there, right? And so it actually turns out that it's even worse on the browsers. And I'm going to actually let you talk about this.
Okay. So yeah, to reiterate Josh's point, and Kelly's, the mutable state causes problems because everybody goes around and makes defensive copies, or they have people with copies of their objects pointing to their internal state, which is just basically bugs waiting to happen. So there's several reasons why it's bad from a purely architectural perspective. But also, as we've switched over, okay, anyone ever seen this graph? One of our engineers at Google discovered this not too long ago. I'll give you a quick synopsis. This is this is performance of, let's see, was this adding to a vector? Is that what I think it was something like adding to, right. Oh, adding global objects, okay. This is the time required to add a certain number of global objects described on the horizontal axis, or maybe added to a vector, one of those two. It's going to be roughly the same problem. On Firefox, that's the red line. Can anybody guess what color blue represents? Turns out that IE has quite possibly the worst garbage collector ever written. And so that's a line, right? So roughly speaking, the regression there is a line. But when the performance of adding, or the cost of adding an object to an array goes up linearly, the performance of most algorithms written on top of that go to n squared. That's really bad. And what's happening is their garbage collector triggers on constants. Constants like 256 objects allocated, constants like, what's the other one? A certain number of string bytes allocated. There's a few little weird constants in there. It's non-generational collector. So you end up with this performance where you're constantly triggering the garbage collector, which is driving your total performance down through the floor. That's the reason, as Kelly was alluding to, that in a web browser, if you can avoid allocating a whole lot of objects, you're going to be in much better shape. And to reiterate a point he made earlier, you don't worry too much about this in your application code, because the cases that are most likely to trigger this are libraries that you're forced to use that force you to instantiate a lot of transient objects. Your application code probably does not have as many of those, although sometimes, maybe in, say, data model code or whatever, you might find yourself instantiating more objects than you need to. But that's something that's a lot more rare. But when you're designing library code, it's really convenient and really tempting to define things like dimension objects. And actually, I would argue it's not even convenient. Most of the time, x comma y would be just as easy as new dimension x comma y, except fewer characters. So it's not, again, OO is not a goal. It's not meant to be there just for purity. Use it as a tool to achieve an actual goal.
And by the way, I actually didn't put his name on here, but this was work published by Dan Pupias, who's a Google engineer. And our final one, sort of a catch-all. We really believe this one too. Read effective Java. This is I think most of you saw Josh talk. This is an excellent book. Do you want to say anything about this book? This is an excellent book.
What you just said.
Yeah. It has many of the things that we've actually talked about are just sort of second-order derivatives from things that appear in this book in the first place.
About the small object not created, this is obviously contradictory to how you would do things on your regular Java. Create all the objects you want, don't create the object pools, let the garbage collector do its thing. So should we start, like I've got cases where I do want to have router objects that keep things together.
Do we need a mic or anything? Can people hear? Okay.
Should we use mutable? Should we, if we need to have small objects and regularly use them
Yeah, and so basically the question he's asking, he said that I'm writing in regular Java, it's often okay to create these smaller objects because I have the virtues of a generational garbage collector. And he's asking about what would we recommend in terms of cases where you have to create small objects in GWT. Would you recommend things like the flyweight pattern? I'm going to say one thing, and I'm actually going to let you answer the core of this. But I'm going to say, let me also remind you, we're talking about library code. So this is one place you don't want to focus too hard if it's application code. But you have some passionate feelings about the flyweight pattern, so I'm giving it to you. I think you do anyway. Well, maybe it's Bruce who has more passionate patterns. Okay.
It's a good idea, certainly over the object pools. In general, anyway, I find the flyweight pattern a lot more effective in practice because it's a lot easier to write, and it really does solve the problem fairly well. I think the main advice that I would give here is, and this is the opposite of what we just said, don't prematurely optimize. And I think the crux of the issue here is the definition of premature. Premature is when you know it's going to cause a problem or when you don't. That's the dividing line. When I'm writing library code and I have the option of creating a dimension object or letting people just pass in a pair of ints, I have good reason to believe that is going to cause problems for a lot of people because people are going to build abstractions on top of this. It's going to be passed into leaf methods very frequently. If I'm writing application code where I do in fact start having this problem, like I'm allocating a lot of little objects and it really does start kind of sucking on IE, it is important to be aware that this issue is there. And it just architecturally know that you do have options like the flyweight pattern to deal with those issues. The same thing can happen in Java code. It just happens at a slightly lower level. To use the Gang of 4 example for the flyweight, if I created an object for every glyph in a text editor, it would be guaranteed to suck for at least the next 50 years on any machine that we can imagine. So that would clearly be a bad idea. That's one I can probably know a priori that's going to be a problem. But in the middle ground, there's this fuzzy territory where I should be able to create objects, but 3 months from release, it starts to cause problems on IE, and we say, wow, what can we do about this? Be aware that you may have to back out of those abstractions at times. Hopefully not most of the time, and I've not seen that too much in application code crop up. But if it does, it is at least design your objects with, like, for example, perhaps to define them to an interface that would allow you to apply a flyweight pattern fairly easily if you had to. So if you get the sense that it might become a problem, prepare for that eventuality. And that's something that's really going to be application specific, though. It's hard to give solid advice on that, but at least be aware of where you might end up so that you can prepare for it. But don't do it across the board in your application code. Most of the time, it's never really an issue.
And I just add that to sort of point back to another one of the practices we listed, and a lot of times you can actually see these by use. You know that basically that this is potentially a hot spot where you're going to create a ton of transient objects. I mean, in a lot of ways, the thing we talked about with using HTML over widgets is related, right? In that you're creating a bunch of objects that you don't necessarily need. So, even in UI libraries where you often have a lot of widgets representing, for instance, large data grids, those are classic areas where you're going, I don't really need all these objects. And so the flyweight pattern becomes very appealing in those areas.
Can I say one more thing to that?
Yeah.
Not to thrash on this topic, but a good discriminator I found oftentimes is look for the boundedness of the problem. What is the order of magnitude that I'm going to be looking at? And is it fixed, or is it simply going to grow without bound? So I was talking to someone the other day about moving data onto the client to do really fast sorting for a list of messages or something like that. I said, well, how many messages are there going to be? 10, 100, 1,000, 10,000, what's the order of magnitude? And is there a limit to that? If there's not a limit to it, you better be prepared to deal with a case where there's too many, which means you've got to deal with the more complex abstraction of having some data on the client, some data on the server. It's not quite the same problem, but to Kelly's example of the table, if you have a table that's going to grow without bound, be prepared to optimize it because there will always be that user who puts 100,000 in there when you thought there were only going to be 500. And also take advantage of the opportunity to bound it. If you have a way to bound it where the UI is still going to be quite effective, but you can have better performance guarantees, then that's something worth considering as well.
Cool. Who was, you want to go, John?
I just realized we stole the mic.
Oh, do we have the question mic? All right. Actually, okay. What's that? Do you want me to run back and forth? Okay. Well, or I can run.
We can do both from the audience.
Okay.
A couple of other points on the IE number of objects. One thing that we've talked about, and I don't know if it'll ever actually happen, but there's the opportunity for the compiler to actually solve the problem for you by reusing objects in the generated code. Other things you can do to work around it is like have parallel primitive arrays and access the fields out of those arrays instead. And we do some of that in the libraries to avoid the problems for you. So as long as you're using the library code, you generally aren't going to have to worry about that. It's when you're writing your own libraries.
I just want to, oh, sorry. I just want to say briefly, John, will you please write that patch that does the recycling?
Yeah, I was just I was wondering about the rich text area API, library API. It's got sort of a divergence between browsers, and I was just kind of with the get basic formatter and the get extended formatter, and I was wondering, if you have any comments on that, or if we'll see more of that type of thing in the future.
Okay, now I wish I hadn't volunteered for this.
Yeah, sorry about that. I don't know what's up with the mics. So yeah, I can definitely comment on that. That was one that involved a lot of hand-wringing. So for anyone who's not seen this, a rich text area has these formatter, they're sort of API objects, if you will. You say area.getBasicFormatter.getExtendedFormatter, I believe is the names. That was one where we really, really wanted to support rich text. Everyone's clamoring for it. Well, what do you do on Safari 2? Our original answer to that was you get a text area, deal with it, because it didn't seem to work very well. But with a lot of experimenting and wailing and gnashing of teeth, we eventually figured out there is actually a useful core set of functionality that is available on Safari 2. And this is also done. I mean, 1.4 was released some time ago, and Safari 2 was still the only browser on Macs for the most part that most consumers would use. So we really thought it was very important to support it. So how can we bifurcate this API in such a way that it is sufficient on Safari 2? It exposes to the fact to the client, to the developer, and this is actually a really important point. It exposes to the developer in a very, I think, a reasonably clear way what it is you can and can't depend on. It forces you to make that decision from a UI standpoint. So, for example, the rich text toolbar that we created, that it was just in the kitchen sink. We'll make that a real widget sometime soon. Reacts to that by turning functionality on and off. Those interfaces are also written, to go back to a previous point, in such a way that the code to support them will go away if the browser does not support, say, the extended functionality. That was a tough decision, though, because it really is. I really wanted that to not have to be the case, but we had to either not support rich text at all or not support Safari 2, both of which were kind of non-starters. So this was the best compromise we could come up with. One day I would like to see all browsers return get extended formatter, which will happen as soon as Safari 2 finally bites the dust and goes away, and everybody's on Safari 3, so hopefully that won't be too long.